Hello, welcome back. We are covering polynomial functions and their graphs. I will break this up into 4 videos, so this one is part 1 of 4. Okay, so polynomial functions and their graphs. And what we're going to cover in this video is the end behavior of their graph. Okay? All right, so let's start off with what a polynomial function is, or what some examples are. You've already worked with polynomial functions. Okay, so a linear function, that's a polynomial function. So it looks like this. That's a polynomial function. Quadratics that you have worked with, those are polynomial functions. So 2x squared, something like this. 2x squared minus 3x plus 5. Okay, and a degree 3. So like 4x cubed minus 5x squared plus x minus 8. Okay, so all of these are examples of polynomials. Okay, so in general, what a polynomial looks like is this: p of x, which equals to, and I didn't want to give this to you first because it looks so scary and abstract. Okay, so it looks like this: a sub n, that's just, instead of using like A, B, C, D, right? Because we would eventually run out of alphabets. So instead of using A, B, C, we use A1, A2, A3, A4, A5. That way we never run out of the alphabets, okay? All right, so that just represents a constant. So you have some number here, and then x to some power. And then you have this next one over here, x to n minus 1. And these are related so that if this is 5, this is 5 minus 1, which is 4. So if this is 5, this is 1 less, which is 4. Okay. And then the next one has some number here, and this one is 2 less than this one. Okay. So so if this is 5, this one is 4, this one's 3. So it's basically going in descending order: 5, 4, 3, 2, 1, 0. Okay, but this is just sort of a general way to write it. Maybe it's a 5, maybe it's a 27, right? Okay, plus a1 x to the 1 plus a0 x to the 0. We don't write x to the 0 because x to the 0 is 1. Okay, so we just leave it as a sub 0. Okay. So this is the general form of a polynomial where n is greater than 0. Okay. And this here is the leading term. So once you have it in descending order, that first term is called the leading term. Okay. And that is going to play an important role. This one over here, this one is the constant term. This is the only one that does not have an x. Okay, And then the coefficients of this polynomial are just those an minus 1, an minus 2, all the a's. Okay, so the coefficients are a sub 0, a1, a2, a3, and it keeps on going all the way to an. Okay, and an, you can see an comes from the leading term. Okay, and so this here, an, is called the leading coefficient. Okay. And again, the leading coefficient, the leading term, the constant term, these will all play a role in some of the things that we're going to be doing. Okay, so for example, if I have this polynomial 3x to the 5th plus 6x to the 4th minus 2x cubed plus x squared plus 7x minus 6, then we can see here that the leading term, this is all in order. So the leading term would be this one over here. So the leading term is 3x to the 5th, and the leading coefficient would be just the number. So that would be 3 in this case. Okay. And we see that this here is a degree 5. This here tells us what degree polynomial we have. That's kind of a sloppy 5. Okay. And we see that here the constant term is negative 6. Okay. All right. And the other coefficients, would be the ones that we did not mention yet. So that would be this here, positive 6, negative 2, positive 1. So if you don't see a number there, it's understood to be a 1. Take the sign of this. So that's positive 1, positive 7, and we already talked about negative 6. So the other coefficients are positive 6, negative 2, positive 1, and positive 7. Okay? Okay, so we are going to take a look at end behavior in this first video. So let's take a look here. End behavior. And what we're doing is eventually graphing these polynomials, these higher degree polynomials. So you already know how to graph a line. You already know how to graph a quadratic, a parabola. Okay, so it's these higher degree polynomials, degree 3, degree 4, degree 5, etc. Okay, so one of the things that we need to do in order to graph these higher degree polynomials is to look at what happens on the left end of the graph and the right end of the graph. So we call those the end behavior. Okay, so I'm going to go ahead and just sketch a few graphs here just so you can see what I'm talking about when I talk about end behavior. Okay, so maybe, let me move that back up. So maybe you have a graph that does this. Okay. And so this here is the left hand behavior, and this over here is the right hand behavior. Okay. This is the left hand behavior. This is the right hand behavior. And so what we want to do, you don't have to copy this part down, but if you look at a graph, right? We have that's the x-axis, right? This is the y-axis. You don't have to copy this down. Don't copy this. Okay. And what happens is the left-hand side, so if we go this way, right here, let me just change this to, let me go here. Is that a highlighter? Okay, so if I go here, and let me use this. Okay, so if I go here, the left, if I keep going to the left, I see that my x's are positive. I mean negative, right? I see that my x's are negative, right? And so what happens is we say, oh, okay, well, as, oops, let's erase that. And so what we do here is we say, okay, well, as x goes towards the negatives, towards the negative numbers, like this over here. Okay, so as x goes towards the negative numbers, we see that my graph goes towards the negative y values, right? Because we see here that downward, the y values are negative, right? And that's what's happening with our graph. As we go left or towards the negatives, as x goes towards the negatives, right? Then my graph, my y values go towards the negatives, right? Okay, so that's what I want to write down. Okay, so I would say as x goes towards negative infinity, my y values go towards negative infinity. Okay. All right. And let's take a look at what happens here on the right hand side, the right hand behavior. Okay. So when we look at the right hand behavior, let me change that to purple. Okay. All right. So as I go towards the right, the x's are going towards positive infinity, right? Okay, so my right hand behavior is as x goes towards positive infinity. Well, I see my graph here goes upwards, right? It goes upwards. And if we take a look here, upwards, the y values are positive, right? So over here, as x goes towards positive infinity, I notice that my y values go towards positive infinity. Does that make sense? So left-hand behavior means x's are going towards negative infinity, and our y values are going downward. But the right-hand behavior, the y values are going upward towards positive infinity. Okay, and left-hand behavior, that means x is towards negative infinity. Right-hand behavior, x is towards positive infinity. Okay, so that's what these symbols mean. Okay, I'm going to go ahead and erase this part. You didn't need to copy that. All right, let's take a look at another graph. Okay, suppose that you have this graph. Suppose that you have a graph that does this. Okay. All right, so over here, the left-hand behavior, okay, the left-hand behavior is as x goes towards negative infinity. Well, we see the left-hand behavior, which is x going towards negative numbers, right? We see that the graph goes up. So the y values go up, so towards positive infinity. And then over here, On the right-hand side, remember, right-hand behavior is as x goes towards positive infinity. That's right-hand behavior. Okay, as x's go towards positive infinity this way, my y values go up. So y goes up, positive infinity. Okay, and let's take a look at one more. Let's take a look at this one. Suppose I have that. So let's take a look at the left hand behavior. So left hand behavior is as x goes towards negative infinity. Okay, x goes towards negative infinity is the left hand behavior. Okay, so what happens to our graph when our x's go towards the negatives? As we go towards the negatives, towards negative infinity, our graph starts to drop. So it starts to go, our y values start to go downward. Okay. And then over here, as x goes towards positive infinity, that's that direction to the right. As we go to the right, that's as x goes towards positive infinity, we see that our graph starts to drop. Our y values drop. Okay. So our y values go towards negative infinity. Okay. So that's what we mean about the end behavior. What is happening on the left hand side of the graph and what is happening on the right hand side of the graph. But instead of saying left hand side, we just say x towards left negative infinity. Instead of saying right hand side, we say x towards positive infinity using all these symbols. Okay. All right. So again, we are going towards graphing. Okay. So we want to move towards being able to graph polynomials. Okay. And when we're graphing polynomials, what we need when we graph these polynomials is the end behavior. So we need to determine end behavior. Okay. And we also need to determine the zeros. Okay, the zeros of the polynomial. Okay, so what are the zeros of the polynomial, you're asking? Okay, aka the x-intercepts. And hopefully you know how to find the x-intercepts. You let y be 0, and then you solve for x. All right, so finding end behavior. And of course, my second video will be determining the zeros. Okay. All right, so finding end behavior. Because we want to be able to graph it. We can find it if we're given the graph, but we're going to use it to determine the graph. Okay. All right, so the way we find the end behavior is we use the leading term. So you need to make sure it's in descending order. So you use the leading term to determine. Okay. And we are going to substitute positive infinity and we substitute that positive infinity into the leading term. Okay, so use the leading term and you substitute positive infinity, because there's an x, right? Like if I show you up here, but let's back up. So this is the leading term, and the leading term will always have some x in there, right? And so you're going to substitute positive infinity in for that x, okay? And when we substitute the positive infinity, what we do is find the right-hand behavior. And sometimes students get hung up about substituting positive infinity. If positive infinity is just too abstract for you, then use positive 1 billion, okay? And then we substitute negative infinity, or if that's too abstract for you, then just use negative 1 billion, okay, to find the left-hand behavior. Okay? All right, so let's take a look at an example. All right, determine the end behavior. Determine the end behavior, and I'll just write that once, and we'll do several. Okay, let's do this polynomial. P of x equals negative 2x to the fourth plus 5x cubed plus 4x minus 7. All right, so here is our leading term, right? Okay. So this is our leading term. This is what we use. Okay, so let's do our left-hand behavior. Okay, so for our left-hand behavior, left is negative for the x's, so we're going to plug in negative infinity. Okay, so left is negative, so we'll plug in negative infinity. So what we're really doing is plugging negative infinity in here, okay? And then we get negative 2 times negative to the fourth power becomes positive. And then we get this very big number, right? Positive infinity to the fourth is just even bigger, right? It's infinity. Okay. But then times negative 2 just gives us a negative result. And that's all we're really trying to figure out. What sort of result do we get? Do we get a negative result or do we get a positive result? Okay. And that's what we're trying to figure out. And the way we figure out whether we get a negative result or a positive result is by plugging in negative for the left-hand behavior, plugging in this negative infinity. Again, if negative infinity is too abstract for you, then plug in negative 1 billion. Okay. And then see what sort of result you get. Okay, so negative, when I plug in negative for the left-hand side, negative infinity, negative to the fourth power becomes positive, and then this becomes very large, times negative 2 is negative. Okay, so I know what happens on the left. My y values go towards the negative, so it falls, it points downwards. Okay, so now I can write it formally as x goes towards negative infinity, my y values go towards negative infinity. Okay. Let's go ahead and do the right-hand behavior. The right-hand behavior x goes towards positive infinity. So I'm going to go ahead and plug in positive infinity into the leading term. Okay, again, the leading term is negative 2x to the fourth. So I'm only using the leading term. Okay, because when you do infinity to the fourth power, that's going to overtake whatever sort of result you get over here. Okay, so positive to the fourth power will give me a positive result. And then positive infinity to the fourth is just really huge, times negative 2 is negative, right? So on the right-hand side, my graph will be falling as well. Okay, so as x goes towards positive, towards the right, my y values, my graph starts to fall. Okay. And so what happens is we know on the left-hand side it falls, and we know on the right-hand side it falls, and then what happens is in the next video we'll take a look to see what happens in between. So, but we know that's going to do something like that. Okay, maybe not quite this graph, but it does some sort of a doodle in the middle, and but it falls on the left and it falls on the right according to this. Okay. All right, let's take a look at another one. Okay. Let's suppose that we have this one. P of x equals 3x to the fifth minus 5x cubed plus 2x. Okay. So let's go again. Here is our leading term is 3x to the fifth. So we're going to do exactly what we did here. Use just the leading term. Okay, so right here we have our leading term. Okay, so we'll start with the left-hand behavior. And x is negative towards the left. So we're going to plug in negative infinity. Negative to the fifth power is still negative. Okay. So over here, negative infinity, negative to the fifth power is still negative. And then infinity to the fifth power is still there. Okay. And so here we see that we will end up with a negative result. Okay. So as x goes towards negative infinity, our graph will fall. Okay, let's go ahead and do the right-hand behavior. Okay, so the right side, x goes towards positive. So we're going to plug in positive infinity. Positive to the fifth power is still positive. And then we have infinity to the fifth. And so this is going to stay positive. All right, so on the right-hand side, our graph will climb. We'll go upward. So as x goes towards the right, positive infinity, y, our graph, y values will go up. Okay. So the left-hand side would be going down. The right-hand side will be going up. And in the middle, we have some sort of a doodle, but it ends up looking something not quite this. Something happens in the middle, but this is the left end and that's the right end. Okay. All right, try this one. Try this. P of x equals, okay, I might have to do this one with you. Okay, 2x plus 1 x minus 3, 3x plus 2. All right, so you need the leading term. There's an easy way to get the leading term here. You don't have to multiply this all out. If all you need is the leading term, do not multiply this all out. That's going to take a lot of work. And you don't need all the terms, right? Like here, we didn't use these terms. Same thing here. We didn't use all the terms. We only use the first term, the leading term. Okay? So don't multiply these all out. The way you get the leading term here is by multiplying the lead in here, the lead in here, and the lead in here. Okay? So the leading term, you're going to multiply the leading term here with the leading term here and the leading term here. So that's 2x times 1x times 3x. And so the leading term is going to be 6x to the third. Okay, so that's going to be your leading term. Okay, so now go ahead and try to find the left-hand behavior and the right-hand behavior, and then come back and check your answers with mine. Okay, hit the pause button. Okay, so starting with the left. All right, so we're going left x's are negative, so I'm going to plug in negative infinity to the third power. Negative to the third power is still negative. So I'll put it on the outside. And then we'll have the infinity to the third. Okay, so then here we end up with a negative result. Okay, so then as x goes towards the negatives, y also goes towards the negatives. Okay, the right-hand behavior. So that's where x's go towards the positives. So I'll plug in positive infinity to the third power. Positive to the third power is positive. And then we have our infinity to the third. All right, so this is going to be positive. All right, so as x goes towards the positives, our y values go towards the positives. Okay. All right, so left side, it would fall. Right side, it would go up. And this would have some sort of graph like that. Okay, something like that. Who knows? Something similar. Okay. Okay, so that's how you find end behavior. Stay tuned for my second video coming up on finding zeros. Once we are able to find the zeros, then we're able to kind of develop this squiggle that's in between here. Okay, but we do need the zeros to figure that out. Okay, I will see you in the next video. Well, not really see you, but you know what I mean.